This problem here is similar to number 13 in section 3.2, and it's going to be number 13 in the textbook. The textbook problem actually refers us back to section 3.1, and what we're trying to do is maximize this function. This is the earnings of the driver. Maybe you remember that problem. You get $13 for every crate of cargo A, $9 for every crate of cargo B. This one we know is 0, 0. This point here, this is the intersection of this line and this line. So we can find those by setting that point of intersection by setting these two lines equal, or these two equations equal, and solving for both x and y. So if we set these two equations equal to each other and solve it for y, it's going to look like this. We're going to get y is 2x, but y is also negative 1/2 x plus 50. This again, the LCD here is 2. We're going to multiply everything by 2, so we'll get 4x equals negative x plus 100. How about if we subtract this x, or add this x, we'll get 5x equals 100. Divided by 5, we'll get x is 20. And then, substituting into this simple equation right here, we'll get y. So if x is 20, y is twice that. Y is 40. So here's the point we get. We'll get 20 and 40 as this point right here. Now, to get this point, we're going to set this equation, these two equations equal to each other. So what we're looking at here is, and if we just solve this equation here, what we're going to get is this. We're going to get x is 60, y is 20. You can verify that if you like. We are going to get this point right here, 60 and 20, and that is this point, 60, 20, is this point right here. And this point right down here, this is just going to be from this equation where y is 0. Right down here, y is 0. So if we solve this equation here, setting y equal to 0 and solving for x, we're going to get x equals 75. So that would give us this point here, 75, 0, and that would be this point. So let's make up our table. We will have x, y, and 13x plus 9y. And I'll just start here. I'm going to start at this point right here and then move around, say, clockwise. So if I put in 0, 0, put zeros in here, we're just going to get 0. And then let's go up here and get this point right here. Now this point, the intersection of those two lines, that was this one down here, 20 and 40. So we'll get 20 and 40. We'll get 13 times 20 plus 9 times 40. And that's equal to 620. Now, let's catch this point right here. This point of intersection was at 60 and 20. So we'll put in 60 here and 20 here. So we'll get 13 times 60 plus 9 times 20. And this gives us 960. And then to finish it off, let's put in the coordinates of this point, which is this set right here. So that's going to give us 75 for x, 0 for y. So this will be 13 times 75 plus 9 times 0. And that is equal to 975. So when I look back at these values here, I get 0, 620, 960, 975. This is clearly the biggest one. So now we're going to conclude that 13x plus 9y is maximum at 975 when x equals 75 and y is equal to 0. Now, if you remember back to the last section, this really had to do with this trucking problem. So x is the number of crates of cargo A the driver should load on, and y is the number of crates of cargo B the driver should put on in order to maximize his earnings. But in this case, they're not asking for that. They're just asking for what's the value of x and what's the value of y.